Hello everybody. In this video I will teach you the very basic on how to build a dataset with R. Okay, I was so happy that R was installed correctly on the Mac that I recorded previously a new video on the Mac, and in the middle of the video R stopped working. So let's retry and hope for the best. 3 hours. Okay, statistical analysis with R. We shall talk about questionnaires. Even though I believe to be an expert in questionnaires, well, it's not officially my subject, so I will leave a lot to other courses, if they exist. But I will anyway try to teach you some tricks, the basic of how to build a questionnaire, because it's strictly related to variable organization, so how to distinguish variables. Because the way you organize your variables is crucial has crucial effect on how will you analyze them. In the entire course we shall talk about descriptive analysis, okay, and graphical analysis, and finally the statistical test, which will let you build a complete scientific article or carry on a complete scientific statistical research on any kind of data. Okay. We skip these things which I have already seen. Okay, let's talk about variables. We distinguish variables into 3 major types. There are a lot of subtypes, but let's stick with these 3 types. The first one are the scale variables, also called numeric variables. These are variables which have an intrinsic mathematical meaning. Okay, it means that you can do mathematical operation. But it does not mean that you want to do mathematical operation. Is it possible that whenever I record a video there is an helicopter or an airplane passing over me? Okay. It does not mean that you want to do mathematical operation, but it means that you could do mathematical operation. Okay. Typical variables are time, anything related with time, so dates, for example. Okay, even years. Okay. An age, the weight of a person, a distance measured in kilometer. Okay, a length, number of children, gross domestic product. You can notice that they can be real numbers or integer numbers, so numbers with digits after the comma, or numbers without a digit after the comma. Number of children is an integer number, while weight can have numbers after the comma, so it can be a real number. Okay, it doesn't matter, both are scale variable, because with both you can do addition. For example, you can say this family has 3 children, the other family has 1 child, together they have 4 children. Even though you may probably never do something like that, it makes sense. Okay. On the other hand, completely different, there are nominal variables. These are called also categorical variables because they split your population into categories. Some examples: country of residence, sex, degree course. These are variables which take your population and split them into the male and the female. Okay, the bachelor students, the master students, the PhD students. Okay, the students are living in Italy, in Germany, somewhere else. Okay, they have no mathematical meaning at all. Okay, even though sometimes they are represented by numbers, still they don't have any mathematical meaning. For example, imagine I'm doing a research on buses. Bus number 1, bus number 2. Which bus number is it? Bus number 1, bus number 2, bus number 3. These are identified with number, but you will never sum them. For example, you will never say, if I take bus number 1 and then bus number 5, I will reach the same destination as bus number 6. No, it doesn't work like that. They have no intrinsic mathematical meaning. In this case, the numbers are only labels. Okay, so even though sometimes categorical nominal variables are represented by numbers, they don't have any intrinsic mathematical meaning. The numbers are just a label. A way in between are ordinal variables. These are variables which have an idea of order, so you can say which one is the first, which one is the last, okay? But they don't have mathematical meaning. For example, education level, ranking. I can say this person or this thing is better than the other one, Okay, but it's difficult to say if I take a thing and another one, I sum them, how much do I reach? For example, education level, elementary school, middle school, high school, bachelor degree, master degree. Okay, you cannot take 2 elementary school children and summing them and getting a middle school boy. No, it doesn't work like that. But still they are in order, so it's a way in between scale and nominal. Okay. A very famous ordinal variable is the Likert scale. The Likert scale is typically the answer to the question, how much do you like this thing? For example, 1, not at all, 7, completely, I adore it. The cold. Okay. 2 sneezes is a scale variable. Okay. This is an example of a Likert scale with 7 items. So Likert scale can have any number of items, well, at least 3, otherwise it doesn't make sense. Usually they never have more than 10. Okay. For Likert scale, it's very interesting to notice the difference between an odd number of items and an even number of items. If you choose an odd number of items, for example 5, you give to the subject the possibility to choose the answer in the middle, so number 3, which is the neutral answer. If you, on the other hand, choose an even number of answers, for example 4, you don't give the subjects the possibility to give a neutral answer and you force them to take a position. This is a typical trick, so you will see that in several questionnaires that they choose 4 whenever they want you to force to take a position. Okay, as you can see from the slide, in statistical analysis, Likert scales are often considered as nominal or scale variable, usually when they have few categories, or when these categories don't have any number. So in the questionnaire or in the research that you have carried on, you don't see any number, they are considered nominal variables. Whenever these categories have a number or there are many, for example a Likert scale from 1 to 10, they are considered scale, even though it's not completely correct. Okay, let's make an overview on a questionnaire. If I find it. Sleep questionnaire, sleep. Is it possible that whenever I search for this questionnaire, okay, it's a fake questionnaire I built and modified. We will use this data here, so come on. Okay. Okay, let's go through and analyze the variables that we will receive as an answer. So first question, the gender. This is an effect of the Mac. Okay, male and female. You can notice that I used a circle and not a square. This is because usually circle means that you must tick only one. Square you can tick several. This is typically a convention, it's not necessarily like that. Okay, so this is obviously a nominal variable, no doubt about it. Okay, it splits the sample into, it splits the population into the male, the female, and the ones who don't want to tell their gender, their sex. Okay, age. Age is a typical scale variable, even though it's integer. Okay, scale variable. Marital status, single, married, divorced, widow. Okay. Well, this is a nominal variable according to my opinion. Well, if you want to see something, a timeline in life, you can set it as an ordinal variable: single, married, divorced, widow. Even though divorced, widow doesn't follow divorced. But honestly, it's a nominal variable. Highest education level completed. Also, this one is a typical ordinal variable. Primary school, secondary school, trade, undergraduate, postgraduate. And I would never consider this one to be a scale variable. So I will never assign 1 to primary, 2 to secondary, 3 to post-secondary training, 4 to undergraduate, and 5 to postgraduate. Because it really doesn't make sense to take a primary school child, sum it with a secondary school boy, and get a post-secondary training. Okay. Weight and height are two typical scale variables. Overall, how would you rate your general health, physical fitness and current weight. Please note that this dirty trick. I'm making 3 questions, but in the same one, so the person who answers doesn't complain about how many questions am I making, too many, blah blah blah. No, and just stick 3, but in this way I stick 3 questions in the same one. Another trick is to use the same Likert scale. Okay, you just create confusion if you use for the first one a Likert scale with 5 elements, for this one with 7, and for this one with 8. You just create confusion. Likert scale, unless you have good motivation to change them, in the same questionnaire should have the same number of items. These are 3 Likert scales. Again, in theory they are ordinal variables. However, since I explicitly write the numbers, there are so many items, you could consider them as scale variables. Do you smoke? Yes, no? If yes, how many cigarettes do you smoke per day? Well, honestly, can you see, apart from the fact that this is a nominal variable, okay, while this is a scale variable, you will notice that this is totally irrelevant. So it's not necessary, because I could ask simply this thing here, and if a person doesn't smoke, just write 0. Unfortunately, not all the people are so smart, and if I just ask this thing, somebody will not answer. But not answer is not 0. A no answer is not 0, so I will never know whether that person didn't answer because it's 0 or because he didn't want to tell me. So I had to ask first whether they smoke, and then, in case, how many cigarettes do you smoke per day. Okay. But you can simply, the people who answer no here, set 0 here. Okay. It's funny that in the real data I collected, there are people who answer yes here and write 0 here. Well, it can be. But there are people who write no here and write a number here. Okay, they have not clear idea. Not clear ideas. Okay, anyway, this is a scale variable. The relevant part of this question is a scale variable. How many standard alcoholic drinks do you consume on an average day? Seems strange, but a person who doesn't smoke doesn't answer to this question, usually. A person who doesn't drink answers 0 with this question. So the use of 0 is strange in the people. So beware what the people can answer if you ever build a questionnaire, because not all the people have the same way of thinking as you. It is a scale variable. How many drinks containing caffeine do you drink per day? It is also a scale variable. Generally, how many hours do you sleep you get on weeknights, on weekend? These are 2 questions in the same one, and 2 scale variables. How many hours of sleep do you think you need? Scale variable. Have you trouble falling asleep? Do you have trouble staying asleep? Are you aware of waking up during the night? These are 3 binary nominal variable. So yes, no. Yes, no, it's yes, no, and the sex is a binary nominal variable. So a nominal variable with 2 values. Binary nominal. This is a non-binary nominal variable because it has yes, no, sometimes. 3 different categories. You could claim that this be a ordinal variable. So no, sometimes yes, or if you prefer yes, sometimes no, but honestly doesn't change too much. I would consider it a nominal variable. Would you describe yourself as a light sleeper? Yes, no. Another binary nominal, binary nominal. How satisfied are you with the amount of sleep you get? Can you see I used the same Likert scale as before? I had no good motivation to change it. And especially don't invert. Don't invert this. So don't say here very satisfied and here very dissatisfied, because the people will answer wrongly. So Likert scale, ordinal officially, we could claim it to be nominal. How would you rate the quality of your sleep? Very poor, poor, fair, good, very good, excellent. It's typical ordinal variable. Okay, and here I would ask myself whether I could consider it a scale variable. It has 6 categories in perfect order. However, it doesn't have any number, so the people don't get a numerical meaning behind. So I'm unsure whether I could consider it to be a scale variable. Another suggestion whenever you build this kind of let's say ordinal variables, pay attention to the words that you use, because it happened to me that we choose the word, we didn't choose the word, well, we choose the word correctly, but the people didn't interpret them correctly, and many people believe, for example, that this category was better than this one. So here, for example, fair, people could believe that fair is better than good. Okay, and this they will get confused. Okay. Finally, do you ever had one of these in the last year? Can you see that I clearly state the time period? Because if you just say, do you ever had one of these? Okay, a person can answer yes, because he had when he was 3 years old. Okay, and also I state clearly more than one answer, and I use the squares instead of the circles. Okay, sleep apnea, restless legs, narcolepsy, bruxism. Bruxism is making strange noises with your teeth while sleeping. Okay, you can cross one of them, more than one of them. This is another trick. And it's also tricky for you, because many people are tempted to use a single variable for this question. So many people, I see people doing it, and whenever I get a data set with this way, I say bad words to the person who built it, if I know who he, she is, and I have to rebuild it completely. Many people are tempted to code the answer to this question in this way. If a person doesn't use a single variable, if a person doesn't answer anything, just leave that variable blank. If a person answers, for example, narcolepsy, write narcolepsy. If a person answers narcolepsy and bruxism, write narcolepsy, semicolon, bruxism. Okay, this is the nice way to make this variable totally useless, because you cannot analyze it quantitatively. You can analyze it qualitatively, but this course is about quantitative analysis. You cannot analyze it quantitatively. Whenever you have a question which has more than one answer possible, you must split the answer into one variable for each answer. So this becomes basically, did you ever had sleep apnea? Yes, no. Did you ever had restless legs? Yes, no. Did you ever have narcolepsy? Yes, no. Did you ever had bruxism? Yes, no. You don't need to write it like that. You can keep it like this. But when you put a variable into your data set, you will need to use 4 different variables. Apnea, yes, no. Legs, yes, no. Narcolepsy, yes, no. Bruxism, yes, no. Okay. In this way, you will be able to analyze. If a person doesn't cross anything, it will be no, 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 no. If a person crosses everything, it will be yes, 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 yes. Okay. This is much more clear. Whenever you build a questionnaire and you put the data into dataset, it's a good idea to build a codebook. A codebook is an explanation of how your variables are. Well, you can see I added an extra variable here, identification. This is because sometimes, especially when you deal with questionnaires, you need to clearly identify who is who. Or better, sometimes you need to go back to the original paper questionnaire or whatever to check some answers which seems in contradiction, etc., etc. And so you need to clearly make a reference to each case. So you need, especially if you are collaborating with somebody else, you need to talk to another person. Please look at case number 27. There is an incorrect answer here. So you need to clearly identify every case. Then you can see for each variable I say the variable name, this is the variable name, sex, age, marital. You will not write marital status as variable name, too long, so usually you abbreviate it, so sex instead of gender, marital instead of marital status. You can see here, for example, trouble falling asleep, trouble. It's not the best way to abbreviate it, but okay. And you write the answers, the possible answers. And in case you use numbers to code them, you write the numbers. So you will not get crazy later on saying, "Wow, but 0 is female or male." It's clearly written, and that's it. Okay. So you can see how I build it. A little explanation of the variable, okay, because for the name, not always is it clear. Okay. So you can see here sleep problems. Apnea, 1, 2, restless, 1, 2, narcolepsy, 1, 2, bruxism, 1, 2, and I clearly write that 1 is yes and 2 is no, and I keep this one, So you can see 1 is in my questionnaire, 1 is always yes and 2 is always no. Like also here. Okay, don't change things in the questionnaire, you will get crazy. Okay, so The codebook is very, very useful for the other people which need to use your questionnaire, or even for yourself. Let's go back to the presentation. Can I find it? Okay. Missing values. Unfortunately, there will be missing values. In R, missing values are identified with NA, which means not a variable. These are missing values during data collection. It means that the person did not answer, or that the person answered something you cannot understand, or that the person answered completely wrongly, for example, crossing male and female at the same time. Okay. So NaN, on the other hand, is still a missing value, but it means not a number. It means that you have done usually a mathematical operation or some particular operation, and you cannot, which was not possible. For example, suppose you have how much do you gain per year? Okay, it's a number. You imagine it's positive, and you calculate a logarithm. Okay. Unfortunately, there are people who gain 0. There are people who gain negative because they somehow lose money during the year, and the logarithm of a negative or of 0 doesn't exist. So you calculate the log income, which is typical, usually calculating the logarithmic income of people, and you get a result which can't be for some people, and for this R will display NaN, which means not a number. The result of some mathematical operation is wrong. It can be also any other kind of operation, not necessarily mathematical. It's a missing. Well, don't worry too much about missing values, because they are automatically skipped in any statistical analysis. So if you calculate an average, automatically all the NA and NaN are automatically skipped. If you calculate any other statistical analysis, they are skipped. Okay. If you build a graph, they are skipped. And if you do any mathematical operation with NA and NaN, in theory you get automatically NaN, because there is nothing to do. Okay. If you do have missing values in your dataset, you have to insert them. Okay, let's start talking about R. Okay, now let's hope that it works. I'm on the Mac, so you never know. Package manager. I tried 20 minutes ago and it worked. Now you hear a lot of bad words. Cross the fingers. It's doing nothing. It's a loaded. Ah no, oops, the wrong one. Okay, let's see. Nah. Okay, I will leave this one on the video. Is it possible that, can you see I don't have the menu? I can't even close it. This is funny. I need to close it with X, and now I don't know where to click, so I can't close it. I have to force quit it, which is very nice. It's always a pleasure to work with programs or operating system like this. Let's retry, and then in case I will switch to Windows. Fuck. Let's check for updates. No updates. Maybe I have to click here first. Seems that there is something stuck. I swear that I tried before and it worked. Stop the video. 0 on Windows, or here if I can find it, our solution. Attempts, I still get that horrible thing even restarting the Mac. So I have open VMware Horizon Client. If you don't understand what I'm talking about and you're using the Mac, please watch the pre-course as I suggested you. If you're using Windows, don't care. I've opened VMware Horizon Client and now I have this wonderful Windows on my Mac. Okay. Let's see. there are a lot of things, on which I have R portable. Okay. Do I have also? No, I will keep on the Mac the presentation. The situation starts to become complicated. Where is the presentation? Here. So we have to talk about data sets now. My presentation is not relevant. Let's go here. So start R portable. Yeah. Okay, the wonderful R portable which works. Packages, load package. R commander. What is this strange thing? Autodesk. Close it immediately. Okay. It's already slow enough without extra things. Die, come on! In the meantime. We were talking about data sets. Okay. What is a data set? Data set is basically a database table. So, suited for statistical analysis. But why in databases the rows are called records and the columns are called fields, here we change completely terminology just to make confusion. The rows are called cases or subjects. Subjects if you are dealing with people, cases if you are dealing with others in general. So the rows are called cases and or subject, and the columns are variables. Okay, so we have variable body, brain, class, and the cases are case number 1 is the mountain beaver, case number 2 the cow, case number 3 the grey wolf, etc., etc. Okay. Oh, finally. There are some data sets already inside R. I will take one of them just to tell here where are data in packages. Read data set from unattached packages. Car data, for example, contains, let's see, the one I use most is child. It's about election in child in Chile. Okay. View data set, you can view it. Okay. Pay attention that view data set sometimes, in particular on the Mac, doesn't work. Funny, eh? Okay, you can see the cases 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's zoom. And the variable region, probably it is north, the population of that region, the sex of that person, the age, the education, the income, the status quo, which I don't know what is it, and whether they vote yes or no on a ballot. NA, the famous not a variable, NA here. Why here NA is between this kind of tags and here not? Well, because this is a numerical variable. So if you write NA, it's automatically not a variable. It can't be a number. Here instead, it's a text variable. So if you write just NA, it could be NA. Okay, so just to emphasize the fact that that NA is not NA, but it's not a variable. Whenever you have a text variable, it's between these special tags. And okay, a lot. Oh, there are also, can you see also some NA here? Okay, let's dezoom. Okay, if you want to edit your dataset manually, you can go here. However, honestly, it's never a wonderful idea. You can really edit, you can change the things. This little interface, I tell you, on R Commander, it's pretty unstable, so use it with care. Okay, let's see how to build a new dataset from scratch. Something that probably you won't do, but just to show you how to build a new one. Okay, R Commander data, new dataset. First insert all the variables and only then starts inserting the data. So, new dataset. Okay, name Paolo 1. Okay, This is the data editor. Let's zoom. Okay, so this is the first variable. No, where is it? This is the first variable. This is the variable name, not NA. Okay, for example, sex. Okay, add column. Age, add column. Degree. Okay, then case number 1, sex. I will choose 1 for male, 0 for male and 1 for female, so 0. Age 27. Is there a way to delete it? No. Okay, I will have to keep variable 4, I will delete it later. Degree, master, add row. So you can see it's a crazy idea to insert directly the thing from here, especially because the interface it's pretty terrible. Okay. And now I have the Paolo 1 dataset. If you want to view, it's pretty small, as you can see. Variable 4 has a lot of NA. Okay. Okay. So, in my suggestion, if you're building a new dataset from scratch, I write here use numbers for nominal and ordinal variables. So, don't write the category explicitly. Stick with the numbers. Okay, then you will add the labels later. Okay. You can see you will then convert them to factors later. I have a slide dedicated on how to convert these things, so for the moment we don't go through. Okay, let's see 2 important commands. You usually write here the commands and here you see the output. One command is ls open and close parentheses, ls, and you click on submit, or if you don't want to go around, you just right click submit. When you submit and nothing is selected, you are submitting the current line. If you want to submit a command which requires more than one line, you have to select everything. Submit. ls displays all the things that you have in the computer memory. Currently 2 datasets, one called child or Chile and one called Paolo 1. Okay. ls.str open and close parentheses displays the structure of the things that you have in the memory. So you can see currently we have this data set, it's called also data frame, with 2700 observation cases, 8 variables. These are the variables. Region, it's a factor. Factor for R means that it's nominal, with 5 levels. These are the levels. Population, num means scale in R. These are some examples. Factor with 2 levels, num, factor, 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 num. And I have my here Paolo, it's a data frame with only 2 observations and 4 variables. Sex, it's an integer. Okay, it's still scale. The difference that it doesn't have numbers after the comma. And for the moment it's an integer because I did not convert it into a nominal. Okay. Age, it's an integer. Degree, it's automatically a factor since I use text. Okay. You could use text also here after all. And v4, logical because the poor R can't guess what it is since it has only not a variable. Okay. If you want to look at the structure of one specific data set, str Paolo 1. Okay. This will display the structure only of Paolo 1. Okay, can you see this display the structure only of Paolo 1? So in case you have several data sets inside. So these are, especially the first 2 are very important commands because will help you understand what you have. Here you see the data set that you are currently working on if you click or use any menu. In our Commander you can work only on one data set at a time. Okay, it's the data set which is displayed here. If you want to change it, you can change it. Okay. It must be loaded somehow, however. So you can load several datasets into R, but our Commander works only on one dataset at a time. Oh, I see here that you can get also the structure of a specific variable. Let's go. Let's try str Paolo1 $age. This gives you information only on the variable age inside dataset Paolo1. In fact, here it is. It's integer. It has only displays values from 1 to 2. Okay, let's do something else. Child vote. Okay, vote okay. Let's see something which is probably more interesting for you, how to import the dataset. Because I tell you, will not type the dataset yourself, you're not crazy, you will import the dataset. We have already seen how to import them from packages. Okay. If you want a complete list of dataset inside our packages list, here is the list. If you can understand it, monthly deaths from lung diseases in the UK. Interesting. Okay. Close it. No. It's just our commander disappeared. Whenever our commander disappears, look for it here. Okay. You will import them from a text file. Let's see how to do it. First of all, let's see which text file do we have here. Mac, can you go away with a thing? Okay. I have here an import, which probably I built deliberately to import something. Okay. This is a typical dataset text file. The name of the variables are written in the first row, separated with semicolon. Their values are following, separated with semicolon. So it is a, let's say, comma separated value text file. It's called comma separated value because traditionally comma was the separator, but you know, comma creates confusion if you use comma also for the decimal numbers. So I prefer semicolon. Let's try to import this import. Open. So where is our commander? Our commander. Data, import data from text file, clipboard or URL. So name for dataset Paolo2. Variable names in file, yes. Missing data indicator. I think that in this case it's simply left blank. You have to know it, obviously. I think. Where is it? On my local file system. The field separator, the semicolon. The decimal point character, I don't have any idea. Let's take a look at it because. Okay, so the missing is completely blank, I see now. The no decimal, now we don't have decimal number, so it doesn't care. So let's go back here. Missing is space. You have to digit the space because it's a space. Okay, press OK. Now it will ask you where on my desktop. On my desktop of Windows, on our portable, import. Okay, you can see here the note. The dataset Paolo2 has 439 rows and 35 columns. Let's take a look at it. Seems to be imported correctly. Can you see the NA appear correctly? This person, Smoke Num, I guess it's how many cigarettes do you smoke per day. It's similar to the one we have seen before. This person smokes 140 cigarettes per day. Okay. How old is it? 60, okay. Okay. Yeah, fine. If you want to look at the structure, str Paolo2. Okay, you can see here now. We have only scale variable, but this is wrong because, for example, sex, it's not a scale variable. Okay, we will see later on how to convert this kind of things because you typically have this problem that to convert this kind of thing into an appropriate factor with the labels. Okay, but now we see only just to import things. Let's see another file to import. but this is delimited. Okay, this is delimited, which can see has the comma as decimal separator. Let's see whether we are able to import it. Data, import data from text file. Paolo 3. Missing, there are no missing values, so I don't care. This is separated by the symbol, which is called, is a music notation called diesis, but the sharp symbol. You will call it hashtag because you are young, but still it's the sharp symbol. Decimal point character, the comma. No, not word space, other. Okay. This is delimited. 10 rows and 1 column. Very suspicious. Let's see. No, it imported only the year. Why? And why is it on the corner? May I? Okay. Sometimes our commander, it's funny. Okay. No, there are problems in the importing. Let's see. Maybe the problem is that doesn't like at all this thing here. The fact that there is also the 1000 separator. And doesn't like at all the symbol of euro. Which is a bad thing. Let's see. The tab delimited. Oh, it has also the euro symbol. Space delimited. These are the dates. Okay. It's enough with the import. Let's try to import Excel. So to teach you how to import Excel. Importing Excel is even easier. Come on. Takes so much. This time I can't blame the Mac because it's Windows. Okay, it's sheet 1. You import sheet 1. We will import. Okay. So, data, import data from Excel. Okay. As you can see, you can import from SPSS, SAS, Minitab, Stata, other statistical programs. I have written a slide on how to import from SPSS, but I imagine you will find most of your data sets in Excel or in text file. Okay, name Paolo 4. Variable name in the first row, yes. Row names, no. Convert character data into factor. Yes, that's what I want to do it. Missing data, empty cell. Usually in Excel, a missing data indicator, it's an empty cell. So I press OK. It's import.xls. Which sheet? Correctly. It was sheet 1. So choose the sheet correctly. 70 rows and 14 columns. Makes sense. Yeah, can you see in Excel everything is also the dates are imported correctly. If you find data in Excel, it's usually much better. The name, the currency, by price, yeah, everything is fine. Let's see at the structure. Str Paolo 4. Okay, fine. Okay. Hoping that it works, because in some old version didn't work. Export to a text file. It's not relevant for you for building the dataset, but since it will be part of the course, let's put it here. How to export it? Let's suppose I want to export Paolo 4 to a text file. Well, data, where is export? Data in packages, active dataset, export active. It's easy. Export active dataset. You have to decide whether writing the variable name on the first row, whether writing the row names, usually no, whether you want to quote around the character values. Well, usually I don't like it particularly. You must use it if you use, for example, I will use the semicolon, but if you have the semicolon also inside the text, in this case you must use the quotes. Missing values with an A, let's see, little dash. Some people use this one, I hate them. Okay. Let's export it onto desktop as Paolo 4. Done. Let's see the result. Can I get to my desktop? Okay, you can see semicolon, everything's fine. Let's trash it. Okay. This is Paolo 4, fine. Let's see what I have to tell you something about. Okay, importing from SPSS, I just put in case you need it. It's easy, but there is a problem with the dates. As you can see, there is a problem with the Gregorian calendar. Okay, and now the hard topic, how to convert a scale to a nominal ordinal. Well, if you have imported for nominal, if you have already found a data set which contains, for example, M and F for male and female, they will be automatically imported in R as nominal, and you don't have to do anything else, honestly. Okay. If you, on the other hand, have found a data set which contains 0 and 1 for male and female, you have to tell R, first of all, that is not a scale variable, and second, that 0 corresponds to male and 1 to female. Okay. So for the moment, let's stick with nominal. We'll talk about ordinal later on. Okay, let's see. You have a graphical interface to do it, or as alternative, you can type it yourself. Okay. For nominal, probably it's easier to use the graphical interface. Let's see here. Let's change to Paolo 3, which, if I remember correctly, no. Why does it have to go? Okay. Okay, view data set. Okay, this is Paolo 3. Let's convert sex, for example, 1 male and 2 female, another helicopter passing over me. Okay, so data, active data set, convert, manage variables in active data set, convert numeric variables to factor. Okay, sex. Okay, you can use numbers. In this case, it will be a nominal a factor, so a nominal variable, but still with 1 and 2. It's much better to use supply level names. Do you want to build a new variable? No, let's keep it. So let's overwrite it. Pay attention, because if you choose to overwrite it, you must be sure that it's no. Let's build sex 2, or gender. Let's call it gender. Okay. Then I will later on delete sex. Okay. 1 male and 2 female. You can write male if you prefer, but I think M and F is universal. Okay, done. Let's take a look at it. Okay, fine. I will now teach you a little extra thing, how to delete a variable. So let's delete variable sex, if I can do it. Maybe it's already in the slide. No. Remove. Delete variables from data set. So I delete sex, and I will keep only gender. Done. Okay. Okay. You can see that I could do the same using this thing here. Oops. This command here. Let's see if I can copy and paste, because it's difficult, because I am on the Mac here and on Windows on the other side, so I don't think it will work. Let's see. Wow. Okay, so you can change it in this way also. Let's do it with another one. What we have here? Smoke, which is true, it's no, and 1 is yes. So data set, it's Paolo 2, variable is smoke, so I'm overwriting it. Dataset is Paolo Chu, variable is smoke, labels are, let me see again, so 2 is no and 1 is yes, so labels are smokes, comma, not smoke. Okay, I don't trust myself, so if I use smoke 2. So dataset Paolo Chu, variable smoke 2. Ah, sorry, I've forgotten this one. But did I write it? Ah, no, I forgot it also here. There must be this one. Also here. Okay. Let's put some spaces to improve your readability. So Paolo Chu, smoke 2. So I take Paolo smoke and I make it a factor with label smoke and not smoke. The labels are given in numerical order. So the first number, which is 1, smoke, and the second number, not smoke, it's 2. Okay, that's it. Submit. Let's see whether it's correct. So the first person doesn't smoke and has not smoke. Person 9 smokes. Can you see how important is it to have this ID? Person 9, okay, smokes, fine. Okay. So you can do it also by hand. Let's see another thing which is a little more difficult, how to convert a scale to an ordinal. I take for granted that you have now the numbers. So you have, for example, 1, 2, 3, 4, 5, which correspond to elementary, middle, high, bachelor, master. Okay? Because if you have the text, it will not be easy to convince R of which one is the first category and which one is the last category, because R will tend to put the things in alphabetical order. So here the instruction is the following. Can you see? If the labels are not supplied, the existing values are used as category labels in alphabetical order. Okay, if you do it for a variable which is a Likert scale, so which has, for example, 1, 2, 3, 4, 5, 6, 7, and the corresponding labels will be 1, 2, 3, 4, 5, 6, 7, it's easy peasy. You just use ordered and that's it. Let's see whether we have a Likert scale here. Op1, for example. So Paolo Chu, Op1 bis, it's ordered Paolo Chu $op1. Okay, so easy peasy, you don't need to do anything. If you want to keep as labels the numbers, you can do it only for Likert scales. I don't want to see things which could have labels, for example, university education, things like that, in which you, because you're lazy, kept only the numbers. Okay, submit. Let's see. So it's 2 for 2. Let's see here. 2 for 2. Okay. So apparently they are the same, but the difference is that op1 bis, it's an ordinal variable. Paolo Chu. You can see op1 bis ordered factor with 5 levels. 1, 2, 3, 4, 5. While op1 it's a scale. It's a big difference in statistics, because the things that you do with scale are different from the things that you do with ordinals. Okay, so if you want to keep just the original one, it's easy. Let's suppose you want to change them. So for example, let's go to education. So educ Chu, it's ordered educ, comma, levels equal C. And now 1 will correspond to elementary, I'm inventing, 2 will correspond to middle, 3 with high, 4 with bachelor, and 5 with master. Oop, close. Cross the fingers. Okay, pay attention, it's levels and not labels. Cross the fingers. Done. No error here. Sometimes it's a good idea to go here and clear window. Pay attention, because sometimes with clear window it clears also the other window, so pay attention. Okay. Because otherwise there is an error mistake from before and you believe it's the same. Let's see now the structure. Okay, education true, ordered factor with 5 levels, elementary, middle, an A. I didn't understand that this... How can we do it? I think we have to convert it before to a factor and then to... So let's convert it to a factor before. So Paolo Chu, Educ Chu, factor, Paolo Chu, Educ. Let's convert it to a factor first. Okay, with the labels. Okay, let's see. Labels length 5 should be 1 or 6. Because there are 6. Comma PhD. Okay, invent 6th one. Okay. Let's see the structure. And now you can appreciate the advantages of a 4th generation programming language. I jump from an instruction here to another one here, and I submit them in a something you cannot do on standard programming languages. Okay, factor with 6 levels, fine. And now levels. Okay, let's try to convert into an order in this way. That's it. Okay, let's see. Ordered factors and correctly first elementary, the middle, fine. So if you don't mind, I update my slide. So this one is fine for ordered. So this one is for factor setting the labels. Okay, I shrink everything. These are thick slides. This is the kind of slides which I don't suggest you to do in a presentation. Okay. Okay. Fine. Okay. Other things you may need to do it, set a value to NA. Sometimes you have a value which is NA, either because it's completely wrong and it was not correctly recognized as NA. Okay? There are 2 ways to do it. The direct one or the one using the menu. Well, honestly, I prefer the direct one. Okay? It's like this. If you know the case number, dataset, $, variable, open square bracket, case number, close square brackets, this strange error, NA. Easy peasy. Let's do it. For example, I want to set this age here, which seems strange, 21. So case number 2, the age, I want to set it to NA. So, Paolo Chu, $, age, square bracket, which on my Mac it's Alt 5, case number 2, okay, set it to NA. This will put NA in Paolo Chu age at case number 2. Let's see. You see, NA. Okay. If you want to do it for everybody, for example, suppose I want to take all the people below 25 and set them to NA. So in this case, Paolo Chu age, again, Paolo Chu $age below 25. Okay, so you put the condition here. This way you force everybody which has Paolo age below 25 to be set to NA. Submit. Let's see. NA, NA, NA. Okay, you can see it's easy peasy. So there is a direct command if you want. In this case, I set all the people who have a specific value to NA. Okay, but you can use also the smaller or larger. Okay, you can use the command, but honestly, let's see. But data manage variable in the activity data set. Data manage variable in the activity set. Record variables. You take, for example, number of children. Make each new variable a factor. No, in this case. New variable name. No. Record directive. A child larger than 4 equal NA. Wait, I'm not sure. Wait. Let me look at help, because I don't remember every programming language I have to deal with. Ah, no. Oops. $4 to $99. Okay. This way, if you set a number of children from 5 to 99, automatically you will be assigned NA. Let's see. There should be some NA in child. There is nobody. Ah, yes, one here. Everybody has few children. Yeah, the people with 5 children don't have time to answer to questionnaires. This is also a problem with questionnaires. Okay, however, that's how it works. Let's edit. Okay, I don't choose the colors randomly. The blue things are things which must be replaced by you, and the purple things don't have to be replaced. Okay. Okay. Let's do something else. Well, build a codebook. We have already talked about it. Well, I'm pretty sure that at the end of your work you will have built 20 data sets. So to remove a data set, very easy, rm, open round bracket, the name of the data set. If you want to remove all the data set, that's the command, and we'll turn. Because I want you to give me a single RData file with one data set only inside, please. So, for example, suppose Paolo Chu is the good one. So ls, and to get all the data set that I have, and I will rm Paolo 1, rm Paolo 3, rm Paolo 4. Now submit everything. Submit. Okay. How many data sets do I have? 1. Okay. I don't want to receive files with 20 data sets. Now save our workspace as. The workspace is all the things in the memory. And this is what you have to give me. The workspace. Its extension is .rdata. Okay. Now, where to get data sets? Well, since my example was a questionnaire, unfortunately, many of you stick with questionnaires. No, well, it can be a dataset taken from a questionnaire, but there are thousands of datasets around not taken from a dataset, taken, for example, from natural events. Okay, well, I just searched around. Let's see. Let's do a quick search. The internet is really full. You can use, for example, also dataset that you have used in the bachelor course if you prefer. Well, dataset for statistical analysis. 19 free public dataset, free dataset for explanatory statistics, blah 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 blah. 7 public dataset you can analyze right now. Okay. The only problem is that you will need enough variables and enough cases. So look at the dataset. Many times, unfortunately, the dataset contains only one variable because it's, for example, the number of deaths from car accident in UK. So year by year, the number of deaths. So contain only one. That's not good dataset for our course. The dataset must contain several variables. Okay, but I'm pretty sure there are tons and tons of dataset around. I suggest you to take datasets which are in Excel or CSV or TXT, which are easy to import into R. If you find already dataset in R, take it. Again, as I write in my website, if you get a dataset which just has one missing variable, I ask, for example, 3 scale variable, and you have only 2, well, feel free to add 1 and invent the data. So you are, or if you have a data set with 90 cases and I want 100 cases, feel free to add 10 artificial cases or just give me 90. But please do not build a data set completely randomly by you, because in that case all the statistical tests that we will do will yield a no result because it's random, so you don't have any, will yield horrible results. Okay, so search the web or use a dataset that you already have, okay, in TXT, CSV, Excel, or even in R already if you want. Okay, don't take the dataset which are already inside R. I know most of them. Okay, pay attention to my request on the website. I don't remember. Advanced data analysis, advanced data analysis. Where are my requests? Here. No more than 20 variables at least, blah 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 blah. Okay, if you just one variable short, you can add invented data, but don't want the dataset to have only invented data. Thank you. And remember that with quality, I don't mean that the dataset looks nice. I mean that the dataset respects what I write. I don't care whether the dataset is not nice. Okay, that's all.